Okay, everybody, that was an introduction to you to our good little old pit bull, Rocky. Now today we're going to start looking at the most complicated part of two-person strictly competitive games. This is where the genius of John Nash really comes out to show that there are solutions to these games. So I want you to consider this really simple little game here, dictated and shown in this particular table. And this table is in your resonant text as well. Now, let's see if we can find a solution to this particular game. First thing we'll look for, trying to find a solution, is look to see if there's any dominance reasoning here. Well, from R's perspective, there is not, right? Because if column plays C1, R does better by playing R1 than R2. But if column plays C2, R does better by playing R2 rather than R1. Similarly for column, right? If row plays R1, column does better playing C2 rather than C1 because column gets a gain of 1 as opposed to a loss of 1. Whereas if row plays R2, column does better playing C1 rather than by playing C2 for a gain of 1 for column rather than a loss of 1 for column. So there's no dominance reasoning here. And I think if you look at all the three different ways of testing for Nash equilibrium, you'll see that there is no pure Nash equilibrium solution in this game either. There's not a point at this game at which neither player would say there's no reason to change his or her chosen strategy. For example, if they end up on R1C1, well, row would have no reason to change, to go from 1 to -1, but column would, right? To go from -1 to +1. If they wound up on R2C2, again, row would have no reason to change, but column would, to go from -1 to +1, and similarly for the other 2 points. So there is no point that's in which no unilateral changes. None of these points are pass the minimax equilibrium test. None of them are the minimum value in its row and the maximum value in its column. And also, neither of them meet the joint security level, right? Where every person plays their security level, they wind up on that particular point. So there is absolutely no pure Nash equilibrium point in this particular game. Nevertheless, there's a solution to this game, and it involves what we're going to talk about next, and that's the use of what are called mixed strategies.